Welcome to this tutorial on developing a study helper app using the Room Persistence Library in Android, presented by the Programming Professor. In this video, we'll guide you through building an app that allows users to create and manage question sets for study purposes. The app uses a local database to store subjects and questions, and will cover everything from setting up the database to implementing features like adding, editing, and deleting questions. Before we begin, make sure you have Android Studio installed and a basic understanding of Kotlin and Android development. Let's dive in. Developing a study helper app with Room in Android by the Programming Professor. Here's what we'll cover in this video. We'll begin with a quick overview of the Study Helper app, and then look at how Room simplifies database management. We'll explore how to define entities and set up primary and foreign keys. Then, we'll move on to DAOs and the database repository. Finally, we'll walk through how to add and delete subjects and manage questions, including adding, editing, and deleting them. The Study Helper app is designed to help users create and manage sets of review questions. All data is stored locally on the device. The main screen of the app displays all available subjects. Tapping on a subject opens up the question screen, where you can see all the associated questions. You can show or hide the answers and navigate through questions using arrow buttons. There's also an up button to take you back to the list of subjects. The app is built using a layered architecture, which is standard in modern Android development. There are two main layers, the UI layer and the data layer. The UI layer is powered by Jetpack Compose and uses ViewModels to manage screen state. The data layer handles business logic and data storage through repositories and data sources. These sources could be local databases, files, or even remote servers. If you want to follow along, you can download the Study Helper Starter project from GitHub. The package structure is organized into three main sections. In the root package, main activity launches the app, and Study Helper application initializes the repository. The data package includes model classes like subject and question, as well as the study repository, which acts as the access point for all data. The UI package has separate folders for subject and question screens, along with their corresponding view models. The Starter app already includes a few subjects, but only algebra has some questions to begin with. Now let's talk about how we handle data persistence. Android apps typically use SQLite for structured data, but SQLite requires a lot of boilerplate code. Room simplifies this by acting as an abstraction layer. It's an ORM library, which means it maps your Kotlin classes directly to database tables. This significantly cuts down on manual SQL and improves code maintainability. Room is built around three main components. atEntity, which maps a class to a table, the atDAO, which defines database operations like insert and delete, and atDatabase, which ties it all together. In this app, we use Room to store subjects and questions persistently. Before we can use Room, we need to add the right dependencies to our Gradle build files. In the project level build, Gradle.kts, we apply the KSB plugin. Then in the module level file, we do the same and also include dependencies for Room runtime, compiler, and Kotlin extensions. This setup enables Room to generate the boilerplate code for us. Each Room entity class corresponds to a SQLite table. Class properties become table columns. We use the atEntity annotation to define a table and @primary key to identify the primary key. If we want Room to auto-increment the key, we set auto-generate to true. Optionally, we can use @columninfo to customize column names, but it's not required unless we want to override the default behavior. Let's look at an example of an entity, subject.kt. In this class, we define a subject with 3 properties. The ID is the primary key and is set to auto-generate. The title is just a string, and the creation time is captured as a long value, with the column name explicitly defined as created. This structure tells Room exactly how to map this Kotlin class to a database table. Next, we have the question entity, which needs to reference a subject. We use a foreign key to establish this relationship. The @foreign key annotation connects the question table to the subject table. We specify that the subject ID in the question class maps to the ID field in subject. The onDelete equals cascade rule ensures that if a subject is deleted, all its associated questions are automatically removed. This keeps our database clean and consistent. Here's what the question.kt entity looks like. Like subject.kt, it uses @entity and @primary key. It has 3 main fields: text for the question itself, answer for the solution, and subject ID, which links it back to the subject table. The subject ID is marked with @column_info to customize the column name in the database. This setup lets us structure our data clearly and enforce proper relationships between different parts of the app. Let's continue building our study helper app by discussing how we structure data relationships using primary keys and foreign keys. A primary key uniquely identifies each row in a table. For example, each subject and question has its own ID. A foreign key, on the other hand, links 2 tables together. In our case, the question table references the subject table via a subject ID field. This relationship ensures every question is associated with a valid subject, which maintains data integrity in our app. Next, we move into Data Access Objects, or DAOs. DAOs define the database operations we want to perform. The @DAO annotation marks an interface for this purpose, and Room automatically generates the implementation behind the scenes. We use annotations like @query for selecting data, @insert for adding rows, @update for editing, and @delete for removal. Only @query requires raw SQL, while the others are more abstracted. For our app, we'll create 2 DAO interfaces, Subject DAO and Question DAO. The Subject DAO interface handles operations on the subject table. It includes functions for retrieving a single subject by ID, getting all subjects ordered by title, and performing insert, update, and delete actions. The implementation uses SQL queries where needed, like fetching all subjects or selecting by ID, and delegates the rest to Room's built-in capabilities. Similarly, the Question DAO interface manages the question table. It allows us to fetch a single question by ID, get all questions for a particular subject, and handle adding, updating, or deleting questions. The DAO ensures all database operations related to questions are encapsulated in one place and accessible in a consistent way. Now, let's talk about the Room database itself. The database class is the bridge that connects our entities and DAOs. We use the @database annotation to declare the list of entities and set a version number. The class extends Room database and includes abstract methods that return instances of Subject DAO and Question DAO. These methods allow our repository to access and modify data through Room. To implement the database, we create a file called studydatabase.kt. Here, we define our study database class using the @database annotation, specifying both the question and subject entities and setting the version. Inside the class, we define abstract methods that provide access to our DAOs. This setup allows Room to handle all the database boilerplate for us. The study repository acts as the single source of truth for all data operations in the app. It wraps around the Room database and offers a clean API to the rest of the app. We use Room.Database Builder to build the database, specify the context and file name, and add a callback for inserting starter data when the database is first created. The repository then delegates actions like getSubjects or addSubject to the appropriate DAO functions, abstracting the data layer from the UI layer. Inside study repository.kt, we define a callback to populate the database with initial data on creation. This is done asynchronously using Kotlin coroutines. The callback launches a coroutine on the I/O dispatcher and calls a private method to add starter subjects and questions, ensuring the app isn't empty on first launch and provides something to interact with. The rest of the study repository initializes the room database instance and wires up the DAOs. It then provides functions that wrap subject-related operations like retrieving all subjects, getting a specific subject, adding a new one, or deleting an existing one. All of these are launched in coroutines to avoid blocking the main thread. We also add methods to handle questions. This includes functions to retrieve a question by ID, fetch all questions for a given subject, and add, update, or delete questions. Like with subjects, these operations are asynchronous and abstract the DAO logic from the rest of the application. We define the addStarterData function. This method populates the database with predefined content for subjects like math and US history. For each subject, we insert several related questions. For example, under math, we add questions about the y-intercept, pi, and triangle area formulas. Under US history, we include a question about the date of the Declaration of Independence. We also seed additional subjects like computing, biology, and Greek without questions, giving users a more complete experience on first launch. This completes the core data layer setup in our app. With room entities, DAOs, the database class, and a centralized repository in place, we now have a reliable and scalable foundation to support all the question and subject features we'll build on top of it. Everything is wired for persistence, asynchronous operations, and clear separation of concerns between UI and data logic. Now we're going to take a look at how subjects are displayed in the Study Helper app. The subject ViewModel uses Kotlin Flows to retrieve data from the room database and emit it as a subject screen UI state. To make this work, the map function is used to convert a list of subjects into a UI state object. Then, stateIn turns the flow into a state flow scoped to the ViewModel scope, using sharing started while subscribed to conserve resources during brief periods of inactivity. If you're following along in the code, you'll want to replace the existing UI state logic with this new flow-based approach. Also, make sure to comment out some outdated code in Question ViewModel to avoid issues when running the app. In the subject ViewModel, the UI state property is replaced with a flow that maps the list of subjects from the repository into a subject screen UI state. This flow is converted into a state flow using the stateIn function. The sharing started while subscribed strategy ensures the flow remains active as long as the screen is in use. This makes your UI reactive and efficient, updating automatically when data changes without manual refreshes. Before you can run the app with this update, you need to comment out some problematic code in Question ViewModel. This includes lines that try to synchronously fetch data using functions like getSubject and getQuestions. These lines are now incompatible with our new flow-based approach and will throw errors if not disabled. Once they're commented out, the app should compile and run without crashing. To help debug and view your room database in real time, Android Studio offers the Database Inspector. This tool lets you see the current contents of your SQLite database as the app is running. After launching your app on a device or emulator, you can access the Database Inspector from the View Tool Windows App Inspection menu. Once there, you'll be able to explore the study.db file, which includes the subject and question tables. For example, the subject table might show 3 columns and 5 rows of data during testing. Out of the box, the Study Helper app doesn't let users add new subjects through the UI. To change that, we'll use a composable function called Add Subject Dialog. This dialog pops up when the user taps the floating action button and includes a text field to enter the subject name, along with Add and Cancel buttons. You'll need to add this composable to the subject screen.kt file and make sure any necessary imports are resolved so it functions correctly. In the Add Subject Dialog composable, we use an alert dialog to display the dialog UI. The dialog contains a text field labeled Subject, where the user can input the name of the new subject. When the user presses the Done key on the keyboard, it triggers the confirmation handler with the typed subject name. This makes the input smooth and interactive while keeping the logic tightly integrated with the rest of the screen. The rest of the Add Subject dialog includes the 2 buttons, Add and Cancel. These buttons are styled using the material color scheme and are wired to the onConfirmation and onDismissRequest callbacks. When the user confirms, the subject name is passed back to the ViewModel, which will handle adding it to the database. If the user cancels, the dialog simply closes without taking any action. To make the dialog actually appear, we need to track its visibility in the ViewModel. For this, we use a mutable stateflow called isSubjectDialogVisible. 2 new methods, showSubjectDialog and hideSubjectDialog, set this state to true or false. We also update the subject screen UI state data class to include a Boolean that reflects this visibility status. This way, the UI can respond dynamically by showing or hiding the dialog as needed. In the ViewModel, we now use the combine function to merge the subject list and dialog visibility into a single state object. This combined state is converted into a stateflow, allowing the UI to observe both pieces of data simultaneously. Whenever either the list of subjects or the dialog visibility changes, the UI will automatically update to reflect the new state. To complete the logic, the ViewModel adds the hideSubjectDialog method, which sets the dialog visibility flag back to false. Alongside that, the subject screen UI state data class is defined to hold both the list of subjects and the visibility state of the dialog. By managing this state reactively, Compose can respond to changes instantly and render the UI accordingly without manual refreshes or extra boilerplate. To add a subject, the ViewModel now includes an addSubject function. This function creates a new subject object using the provided title and sends it to the repository for persistence. It's connected to the dialog's confirmation button, so when a user enters a subject name and taps Add, the new subject is saved and immediately reflected in the list. This wraps up the entire subject adding workflow and ties together the dialog, ViewModel, and repository layers in a clean, reactive architecture. The Study Helper app now reacts to UI state to determine when the Add Subject dialog should be shown. This is handled in the subject screen, which checks the subject ViewModel's state to see if the dialog should appear. If isSubjectDialogVisible is true, the dialog is displayed. Inside the dialog, confirming will call addSubjectTitle and close it using hideSubjectDialog. The floating action button is responsible for triggering showSubjectDialog, and once a subject is added, the subject grid updates immediately. To enable this in the UI, we add the dialog logic directly into subjectScreen.kt. The composable listens to the UI state via collect as state with lifecycle, and when isSubjectDialogVisible is true, the Add Subject dialog is displayed. Inside that dialog, if the user confirms, the ViewModel adds the subject and hides the dialog. If they dismiss it, the dialog simply closes. Running the app and clicking the plus button should now bring up the dialog and add a subject to the grid in real time. We also update the scaffold structure of subject screen. The top app bar displays the app title, Study Helper, and a floating action button is added that calls show subject dialog when pressed. This connects the UI controls directly to the ViewModel's dialog state, ensuring that user actions are reflected in the UI state and that the dialog logic is centralized. The app now supports bulk actions using a contextual action bar, or CAB. This UI appears when the user long presses on a grid item. It replaces the default top app bar and provides context-specific actions like delete, select all, or cancel. The CAB remains visible until all selected items are cleared or the user taps the up button. This feature gives users more powerful tools for managing multiple subjects at once. To support selection and deletion, the Subject ViewModel introduces a new selected subject state and updates subject screen UI state with is CAB visible and selected subjects. These fields are derived from a combination of existing flows. New methods, select subject, hide CAB, and delete selected subjects, are added to help manage multi-selection mode and remove multiple subjects at once when requested. This slide shows how to update the Subject ViewModel to support subject deletion and selection tracking. We've introduced a new selected subject state using mutable stateflow, which keeps track of which subjects are currently selected. This is combined with the list of subjects and dialog visibility state using the combine function. The result is a subject screen UI state that contains the subject list, selected items, and whether the add subject dialog should be visible. Finally, we wrap the combined flow with statein so the UI can observe it as a state flow. This setup allows the UI to respond reactively to changes in selection and dialog state. The select subject function toggles whether a subject is in the current selection set. Hide CAB clears all selected items, effectively exiting selection mode. Delete selected subjects loops through the selected subjects and removes them from the repository. It finishes by clearing the selection, which automatically hides the CAB. This approach keeps the business logic encapsulated in the ViewModel and the UI as a clean observer. The subject grid composable is updated to accept parameters that control selection mode. These include a Boolean flag for in selection mode, a set of selected subjects, and a callback for onSelect subject. Inside, we use the combined clickable modifier to handle both click and long click behavior. Long presses enter selection mode and trigger haptic feedback, while normal clicks either select the item or open it, depending on the mode. We make these changes by modifying the subject grid composable to add the new parameters and haptic feedback. When a subject card is long pressed, the app provides tactile feedback and marks the subject as selected. If in selection mode, tapping a card will toggle its selection state. If not in selection mode, it will open the subject as usual. This flexible interaction lets users fluidly switch between exploring content and managing it with multiple selection. We also show visual feedback for selection using a check icon. The icon is placed in the top left corner of selected cards and styled with white for contrast. This visual cue makes it easy for users to keep track of their selections, especially when managing multiple subjects. It reinforces the intuitive feel of the app and aligns with standard Android design principles. Each subject card continues to display the subject title centered within the card. The text is styled for clarity and readability, and its appearance remains consistent whether or not the card is selected. This ensures users can always see what each card represents, while maintaining a clean, minimalist design. With these updates, the Study Helper app now offers a more powerful and responsive subject management experience. The UI supports dynamic state-driven behavior, multi-selection with contextual actions, and interactive feedback that aligns with user expectations on mobile. Next, we're adding a contextual action bar, or CAB, to the Study Helper app using a composable called CAB App Bar. This bar appears when subjects are selected in the subject grid. It includes two main actions: a delete button to remove selected subjects and an up button to cancel the selection mode. CAB App Bar is only shown when the UI state indicates it should be visible. To implement this, we insert the CAB App Bar logic into the subject screen and use imports as needed. The CAB App Bar itself is defined as a composable using Top App Bar. It takes in callbacks for delete and up actions and sets them as icon buttons. The back arrow icon triggers on-up click, and the delete icon triggers on-delete click. This layout gives us a clean, reusable way to inject the CAB into different screens if needed, while maintaining a familiar Android user experience. In Subject Screen, we conditionally display either the CAB App Bar or the default Top App Bar, depending on whether the CAB should be shown. When isCAB visible is true, CAB App Bar is used, giving users access to delete and up actions. If no items are selected, the standard app bar with the Study Helper title is displayed. This logic allows the interface to switch seamlessly between selection mode and normal viewing. We add this logic into the scaffold of Subject Screen. When isCAB visible is true, CAB App Bar is displayed and wired up to delete selected subjects and hide CAB from the ViewModel. Otherwise, the standard Top App Bar appears. The subject grid below is configured to show selection indicators and respond to subject clicks or selection toggles, depending on the mode. This completes the dynamic switching of the Top App Bar based on user interaction. Let's shift to handling navigation arguments with Save State Handle. Save State Handle is a key value store that retains root arguments and UI state across configuration changes. In the Study Helper app, the question view model receives a Save State Handle that includes the subject ID argument. This makes it easy to retrieve and use the subject ID without needing to manually pass arguments between composables. The ViewModel factory for Question ViewModel uses createSaveStateHandle to generate the handle. Then, it constructs the ViewModel using this handle and a reference to the study repository from the application context. This pattern ensures that root arguments like subject ID are automatically available and survive configuration changes, while keeping your composable logic clean and focused. Next, we configure the question view model to display the first question when a subject is selected. This is done using Kotlin's combine function, which merges multiple flows into one state flow. We combine the subject data, list of questions, current question number, current question itself, and whether the answer is visible. The filter not null call ensures we only work with valid subject data. This replaces the old hard-coded logic and allows for automatic updates. The UI state in Question View Model is now calculated by merging those flows. It determines the current question to show based on whether there's a valid question ID, if the question list is empty, or if the question number is valid. This logic makes sure the user always sees a relevant question, usually the first one, after selecting a subject. It's a responsive and flexible approach that scales well as the question list changes. To add navigation between questions, we implement two new functions in the ViewModel, PrevQuestion and NextQuestion. These methods use the modulo operator to cycle through the list of questions. They update the current question number and the question itself, ensuring the UI displays the correct data. After adding this, selecting Math and using the left or right arrows will let you move through questions interactively. Inside the updated ViewModel, PrevQuestion moves backward by decrementing the index and wrapping around using modulo. Next question increments the index and loops to the beginning if needed. Both methods update the CRUD question and CRUD question num fields to reflect the new selection. This lets the UI always stay in sync with what the user is viewing and avoids out-of-bounds issues. To allow adding new questions, we introduce Add Question ViewModel. This ViewModel manages the input state and handles saving new questions to the room database. It's used by the Add Question screen composable and includes logic for tracking user input and submitting it. To set it up, create a new file called addQuestionViewModel.kt under UI/question and wire it up as shown in the next steps. The new ViewModel imports everything needed for Compose state and lifecycle integration. It includes a companion object that defines a factory for creating instances. This factory uses createSaveState handle to initialize the ViewModel with the subject ID argument and the repository reference. These dependencies make it easy to build ViewModel instances that are lifecycle-aware and argument-ready. The addQuestionViewModel extracts the subject ID from the root using the toRoot function. It uses a mutable state of variable to track the current question object. There are two key functions. ChangeQuestion updates the current question being edited, and addQuestion sets the subject ID and saves it to the database. This encapsulates all logic needed for adding new questions and keeps the UI reactive and clean. The Add Question screen provides users with a way to input custom questions and answers for any subject. This screen is composed of two main composables: Add Question screen, which sets up the layout and actions, and Question Entry, which renders the form where users input question text and answers. The screen integrates with Add Question ViewModel to manage state and submit the data to the room database. To implement this feature, you'll need to create a new Kotlin file named addQuestionScreen.kt and add both composables, resolving imports as needed using Android Studio's quick fix. The Add Question screen composable includes a scaffold with a top app bar for navigation and title. It receives a ViewModel to handle data and Lambda functions for up and save button actions. The back navigation icon calls onUp-click when tapped. This gives the user a familiar interface for entering a new question, with structure similar to other Compose screens in the app. In the second part of the scaffold, a floating action button with a checkmark icon is added. When tapped, it triggers the ViewModel's addQuestion method and then calls on SaveClick to return to the previous screen. The form content below the button is rendered using the Question Entry composable, which is passed the current question state and an update callback. This allows the input fields to update the ViewModel in real time. The Question Entry composable lays out two vertically stacked rows for question and answer entry. Each row has a large label, Q for question and A for answer, and a corresponding text field. It uses a column to align content and the local focus manager to manage keyboard actions. The layout is designed for clarity and ease of use on mobile devices, giving the input areas plenty of space. The top row of the form contains a text field for the question itself. It allows multi-line input and uses a large font size for readability. The keyboard is configured to show a next action, and padding is applied for spacing. Each keystroke updates the ViewModel with the current question text, ensuring the UI stays in sync with the backing data. The second row of the form holds the text field for the answer. Similar to the question field, it supports multi-line text and uses a 30 SB font size. Pressing the Done key clears focus from the field to dismiss the keyboard. The user experience is consistent across both input fields, and the form is designed to support smooth entry and submission of new content. To allow navigation to this new screen, we update StudyHelper app.kt. A new root called addQuestion is defined that includes a subject ID as an argument. This route links to the Add Question screen composable. When a user clicks the plus button in the question screen, it navigates to this route using a lambda. This lets users add questions directly from the subject's question list. Inside Study Helper app.kt, we update the navigation graph to include the Add Question route. We define a sealed data class under routes for it, then configure the nav host with a new composable that renders Add Question screen. We also configure the question screen route so that when a user clicks the Add button, it navigates to Add Question, passing the current subject ID. This completes the navigation link from viewing to creating questions. In the continuation of that change, we make sure that question screen's on-add-click navigates with the correct subject ID. Then, when rendering Add Question screen, we pass handlers for both on-up-click and on-save-click, which each return the user to the previous screen. This creates a seamless flow where the user can add a question and return to the list without extra steps. To improve the user experience, we enhance the behavior to automatically scroll to the newly added question. We do this by adding an optional Show Last Question parameter to the question route. The Add Question route is updated to trigger this navigation upon save. The effect is that once a question is added, the app not only returns to the list, but also scrolls to and displays the new entry. In the Route Sealed class, we now modify the question route to accept a Show Last Question Boolean, defaulting to false. This allows flexibility in navigation. If it's set to true, the screen can automatically display the last item in the list. This is useful when users add new content and want to immediately see it confirmed in the interface. Inside on-save click of Add Question screen, we update the navigation logic. We first pop the Add Question screen from the back stack, then navigate up to clear it. After that, we navigate directly to the question screen with Show Last Question set to true. This ensures the UI always reflects the newly added data and provides a responsive user flow with minimal manual steps. The Study Helper app now supports showing the most recently added question right after it's saved. This is done by introducing a new property called Show Last Question in the question ViewModel. It's assigned from the root argument using SaveState handle, and when set to true, the app will automatically scroll to and display the last question in the list. This small addition improves user experience by making new content immediately visible. Inside Question ViewModel, we retrieve the subject ID and Show Last Question flag from the root arguments. These values help determine which question to show when the screen loads. This setup uses the same flow combination structure we've seen before, so the change fits neatly into the existing ViewModel logic and keeps things clean and maintainable. The question selection logic is updated to check whether the current question ID is 0 and if Show Last Question is true. If so, it selects the last question in the list. If Show Last Question is false but we still have no current question, it defaults to the first item. This ensures consistent behavior, whether users are viewing or adding questions. The question number and list are also updated accordingly. Next, we introduce a new ViewModel for editing existing questions. The Edit Question ViewModel handles loading a specific question, managing updates to it, and saving changes to the database. It works alongside the Edit Question screen composable. This setup follows the same architecture used for adding questions, ensuring reusability and consistency throughout the codebase. Step 1 is to create the Edit Question ViewModel class and add the appropriate import statements to our file. Then inside the Edit Question ViewModel, we fetch the question ID from the root and use it to load the question using a coroutine. The result is stored in a mutable state property that reflects the currently loaded question. We also define methods to modify and update the question. The first emitted question is pulled from the flow using .first and filter not null to avoid null values and automatically cancel the flow after loading. To build the interface for editing a question, we create a new composable called Edit Question Screen. This composable connects to the Edit Question ViewModel, displays the current question, and allows users to make changes. It reuses the question entry composable we've already implemented, maintaining visual and functional consistency across the app. We start by updating the Edit Questions Screen.kt file according to the following code. The layout for Edit Question Screen includes a top app bar with a back button. The top app bar also contains a floating action button to save the changes. When the Save button is tapped, it triggers two key actions. It calls ViewModel.UpdateQuestion to save the changes to the current question, and then invokes onSaveClick to navigate back. Below that, we see the question entry composable, which displays the form for editing the question. It's passed the current question state and a lambda that updates it as the user types. This structure ensures the screen is both functional and reactive, updating the UI and the database with minimal code. Now we need to add navigation support for the new editing screen. We define a new route called Edit Question that accepts a question ID. Then we update Question Screen to include an onEditClick handler that navigates to this new route when the user taps the Edit button. This wiring connects the navigation logic to the editing workflow, giving users a simple way to modify questions directly from the UI. In the navigation setup, we define Edit Question as a serializable data class in StudyHelperApp.kt. We continue to update StudyHelperApp.kt to include a new composable destination for Edit Question Screen. The Question Screen composable is updated to include a third callback, onEditClick, in addition to onUpClick and onAddClick. When the user taps the Edit button, the app navigates to the Edit Question route using the selected question's ID. This direct connection ensures the right data is loaded for editing without requiring additional logic from the UI layer. To support deleting questions, we extend the question ViewModel with a new method called deleteQuestion. This function removes the current question from the database using the repository. It also updates the state depending on whether the deleted question was the only one, the last one, or somewhere in the middle of the list, ensuring a smooth user experience without crashes or inconsistencies. The deleteQuestion method includes logic for different deletion cases. If there is only one question left, it clears the current question state entirely. If the user is deleting the last question in a list, the method shifts to show the previous one. Otherwise, it simply moves forward to the next question. The question is then removed from the room database by calling deleteQuestion on the repository. This implementation gives us a complete round trip for managing study questions. Users can now add, view, edit, and delete questions in a subject. All of these operations are supported by a shared structure of view models, navigation routes, and composables. Every interaction is backed by the room database, ensuring persistence and stability across configuration changes. Finally, the Study Helper app is a full-featured example of how to use Room, ViewModel, and Jetpack composed together in a modern Android project. It includes entities and DAOs for managing data, composables for UI interaction, and view models for business logic and state management. With dynamic navigation and full CRUD support, it demonstrates how to build robust, real-world apps using today's Android architecture components. Thanks for watching. Let me know in the comments if there are other topics you would like me to talk about. If you enjoyed this video, please like, share, and subscribe for more content on software engineering and technology. See you next time.